All right. So just a quick little overview of graphing tangent. We talked about this with the honors pre-calc group today. If you draw a tangent, it's like x cubed, except there are asymptotes at pi over 2 and negative pi over 2. I call them force fields. X cubed would go, something like this. It would cross those. But this is not x cubed. This is tangent. Tangent actually repeats every pi because the period is pi. Well, because the period is pi, when we calculate, we don't calculate with 2 pi over b like we did with all the others. Tangent is going to be pi over b because only the period for one tangent is pi. So we did this example. We found 3 tangent 4 theta. 3 was my amplitude. Period is pi over b. In this case, b is 4. No c, no d. And when I drew that tangent, purple line, the period from asymptote to asymptote was pi over 4. So we start at 0 and we go half of the period, which was pi over 4. So that's where I got pi over 8. And then I put the negative pi over 8. Amplitude is fake for a tangent. You go halfway between 0 and the force field, or 0 and the asymptote. And if you go in the middle, here it's pi over 16, go up and over. That's kind of where that 3 comes in. It's not really an amplitude, but it's how we're going to graph it. So for this one, A is negative 1/2. So the amplitude is a half, and then it's flipped over the x-axis. What's B for this one? Garrett, what's B? Half again. So the period is pi over a half, which I like, 2 pi. Awesome. And then this one is pi over 2, and that's going to be pi over, it says negative, pi over 2 to the right. And then thank goodness there's no vertical shift, but we could handle that if we had to. So you draw the asymptotes, sketch the tangent going up to the asymptotes, and it says the period here, from here to here, is 2 pi. So if this is 0, where's this asymptote at? Pi this time. How many had that? Good. I think that's the only tricky part. And then if you go in the middle, pi over 2, up and over, the amplitude is going to be what? 1/2. And you could do that down here too, negative 1/2. And this negative just means that it shifted like that. How are we doing? Doing okay? Then it shifts to the right, pi over 2. So I have it labeled pi over 2. So I just move it to the right, pi over 2. So the asymptote here is actually going to be at pi over 2, and this one's going to be at 3 pi over 2. Kind of weird looking, but that's what it does. And then it does repeat infinitely, like that. How many had something like that? Great. Great. Okay, let's draw these 2, and then I think that's going to be enough for today. So secant is 1 over what? 1 over the cosine. So do you remember a bunch of months ago where I taught you how to draw reciprocal graphs and you hated that? Trying to remember the inside-out graphs? Oh, you didn't like those. If we drew the cosine, sketch the cosine graph. In fact, I'm going to sketch it a little bit smaller amplitude. This is going to be 1, and this is going to be negative 1. This is the cosine graph. Does that look familiar? But secant isn't the cosine graph. Secant is 1 over the cosine graph. What's 1 over 0? Oh, so there's going to be an asymptote. What's 1 over 0? Another asymptote. What's 1 over 1? 1. What's 1 over negative 1? Negative 1 and 1 over 1. And then when we do the reciprocal between 0 and 1, what it is going to do is it's going to flip up like that. Yeah, I know. You remember that? Remember the good times? They were the worst. Yeah, but these are kind of fun because all you're going to do is, so we flip those up to the asymptote. It never quite gets there, but it gets pretty close. And so we can fill these in. This is pi, pi over 2, 3 pi over 2, and 2 pi. So how hard do you think it's going to be to graph y equal to 4 secant 3x? Well, let's slow down just a little bit. Remember that this is the same as 4 over cosine 3x, okay? But that looks real confusing. Let's do the ABC thing. A, B, C, and D. I don't see any C or D's, thank goodness. But what's in front of secant 3x? What number? That's the amplitude. How do you think that's going to impact my cosine? How's that going to impact it? This is just going to start at 4. And down here is going to be negative 4. Well, that's easy. I thought this was going to be hard. B is 3. Now, cosine, is it pi over b or 2 pi over b for cosine? One complete cycle is 2 pi. So the period is going to be 2 pi over 3. So one complete cycle is 2 pi over 3. Half that's pi over 3. And then this is 0. So far, so good? Then 1 over 0, 1 over 0, my asymptotes, and then do the flip up. Isn't it ice fishing? Isn't there a tip up for ice fishing? You know, where there's a little lever, and if a fish tugs on the line, it flips it over, tips it over. That's kind of what happens here. It tips up. And there's my graph of 4 secant 3x. Did you ever imagine that you'd be able to graph that when you came in today? Seems easy now, doesn't it? Okay. That's secant. Now, you see what you can do with cosecant. But cosecant, remember, is 1 over the sine of x. So go ahead and see if you can sketch it, and then try this cosecant negative 1/2 cosecant pi x. For cosecant, you draw the sine curve. So I wrote sine of x, sine of x, sine of x. And then I'm going to do 1 over 0, 1 over 0, 1 over 0. That's where this asymptote comes in. And then if this is 1 and this is negative 1, the flip up is just here, here, there, and there. It doesn't cross the force field. And in reality, it keeps going left and right. But whoop. What's that? How many got that? So then, any questions? Nathan, you good? Jacob, you good? All right, now this last one, I bet you don't even need me, but let's just get this together here just to wrap this one up. What did you say A was for y equal negative 1/2 cosecant pi x? What's A? Negative 1/2. That means the amplitude is going to be 1/2, and then it's going to flip over the x. B is going to be the coefficient in front of x, which in this case is pi. So the period, now only tangent and cotangent are the pi over b. This is going to be 2 pi. Ooh, I like it. I love those when that happens. So you start by drawing the sine curve. And then we found the period was, ooh, this is nice, 2. This is a half. This is 3/2. Like it. Then we do the asymptotes. And then we do the flip up. And the only thing I haven't really shown yet is how high does this thing go? Or how low does this go and how high does this one go? Between what and what? Half and -1/2. Now I know you're tempted to just call this negative, this positive, but please don't do that. These will flip, and so these go bye-bye. And that'll be your final graph. You good? That's sine, cosine, tangent, secant, cosecant. I haven't done cotangent, but I'm going to leave that for now. This student from a couple years ago, he liked that picture. All right, go to day 2. Come on, day 2. Where are you? There it is. Day 2. This is kind of some old stuff, which I like. But here are the graphs. So you're going to graph tangent, tangent. Do I have any? There's cosine. That's a good review. These two here, 28 and 30, are thinkers. Little thinkers, not stinkers. You know how to rewrite this. You know how to rewrite this. You're just looking at it and you're going, huh? But try them, and then we'll go over them tomorrow. And then these are the cool ones. You're wondering, why did I have all these butterflies on there? This is a butterfly question. Here's the equation. You're going to figure out what the initial population is, the largest, smallest, and see if we can use your calculator to find when the population reached 4,000 butterflies. I think that should be it. Yeah, that's good. Okay, and this is going to lead into my lab that we're going to introduce tomorrow, that you're going to like. Okay, so day 2, make sure you do these graphs and give the 2 thinkers a try, and number 5, if you can get to 44, 45, and 47, that's great. That's going to be awesome. And I will check those tomorrow.